Let us take a look at this one. If x plus iy whole power 3 is equal to u plus iv, then show that this expression equals this expression. Okay. Now how do we go about approaching this one? If we take a look at ux vy, this u and v are, let us say, in products and in addition subtraction with these x and y terms on the LHS, present in the LHS in the given expression, right? Since they are intertwined, we cannot solve this separately and this separately as we had done for our past few questions, right? We had taken modulus and simplified them together. So such an approach is not possible over here. What do? What we'll do is, we'll try to find u and v first then, right? And that is what we'll begin with. Given that u plus iv is equal to x plus iy whole power 3 implies this is equal to what? X plus iy power 3 can be further written as, this is a plus b whole cube, which becomes a cube plus 3a square b, which is iy, plus 3a b square, which is iy square, which is I square y square, plus b cube, which is I cube y cube. This is what we have, right? Can we simplify this further? Yes. This I square is actually equal to minus 1. Okay. So this becomes minus 3xy square. Okay. There's an x cube over here. So x cube minus 3xy square is actually the real part, right? What happens in what happens in case of imaginary part? What you get is, let's take a I common. This becomes 3x square y. And what happens to this term over here? There's an I cube over there. And what can we say about I cube? I cube is actually I square times I. I square is minus 1, yes. So this is minus y cube. I is already taken out common. This becomes minus y cube over here, right? Okay, so therefore u plus iv is actually equal to this. And on comparison of real parts and imaginary parts, which we get u equals x cube minus 3xy square, and v is equal to, real part becomes equal to real part, v is equal to 3x square y minus y cube. This is what we have. The imaginary part is equal to imaginary part. Now always keep an eye on what is to be proved. We are supposed to prove u upon x, v upon v. You observe that u and v are only present at one locations, and therefore we have found the values of u and v. Now what next? We are supposed to find u upon x actually. Let's try to find u upon x. Can you divide by x on the LHS and right hand side? Yes. Dividing by x, this becomes x square and this becomes 3y square. Okay, minus. And v over y is something else that is required, and v over y is equal to, let's divide with y, this becomes 3x square minus y square. Can you observe that? Yes. The question is asked in such a manner that your calculations become very simple gradually as you move ahead. And now u over x plus v over y is equal to what? U over x plus v over y is equal to this plus this. Let's add them together. What you have is x square minus 3y square plus 3x square minus y square. This is equal to 4x square minus 4y square, which is actually 4 times x square minus y square. That means u over x plus v over y is actually equal to this. And yes, this is the exact same thing that we were asked to prove. That is the complete proof of this particular question, right? It's a complete proof. Yes, that is the complete proof, as you can see over here. And that is all in this question, as you can see.